All right, I'm going to talk about the power that's on the bus. I'm going to go through a little brief description of how it's set up and how it works, and then I'll take you guys on a video and show you the install on the actual bus. I don't have but one color marker for this video. Hopefully you can still follow it. I have DC on one side and AC on the other. This is an inverter charger combo. It's rated for 2,000 watts, continuous 2,500 surge watts. So we'll start with the DC side. There's already a DC system on the bus, which is your start batteries that turns over the engine and works the lights on the bus. The house batteries are also 12 volt, and I added this start batteries also has an isolation switch here. What this relay does is when the voltage, the inverter charger is allowed to pull DC power from the entire bus. Start batteries, house batteries, 12 volt alternator to power the 12 volt house power systems for the bus. To prevent my start batteries from being run down, I have a relay that senses the voltage that's in the start batteries and the house batteries on the positive side of the power system. That relay, whenever the voltage drops too low, shuts off and basically isolates the start batteries out of there's no more power that can come from the start batteries to the inverter or to the house power. It shuts off the start batteries so that the bus can be started later on. Have a 300 amp fuse on the DC side coming into the inverter. I put the little arrows to kind of indicate the flow of electricity back and forth. And on this side is all of the AC power. So you have your AC power in from either shore power, 120 amps, like a regular extension cord and plug, or which 20, maybe 15 in some cases. Generator power in, and then as long as the inverter options, which I'll show you what it looks like here in a minute, are selected, the inverter charger is going to pull AC power to power the 110 volt AC house systems from wherever it has available. So if you're plugged in, it will just reroute it straight to there while it's simultaneously charging the batteries on the bus. And it'll do the same thing if there's generator power coming in. It'll simultaneously charge the batteries while providing AC power to the rest of the bus. If there is no AC power coming in, then it will draw from the 12 volt battery banks and or the alternator into the inverter charger, invert the DC into AC 110, and then populate it back to this is the breaker box and all the 110 systems that are on the bus. So hopefully that makes a little bit of sense. I'll show you kind of where everything came out on the bus. I'm real proud of it. It's super cool. All right, first thing, I'm going to show you the batteries, kind of how they came on the bus. I mean, I had to add an extra battery in a strip because they didn't have, they only had one start battery just to kind of get it going. And then I'll go through and show you the electrical components that we have actually on the bus. So there's what I have in there. Those are my two start batteries, and then my isolation switch, so that that's before I got the relay. I can manually turn the start batteries off, which I would do that even though I have the relay if I was somewhere really remote, just as another fail-safe, so there's no possible way that I could run my start batteries down. I gotta peek over here at the dogs, make sure they're not trying to eat the chickens. Alright, we're looking good. Alright, so we'll come inside of the bus here and we'll actually take a look at the power system as I have it set up. So here's the charge controller for the inverter, and my actual breakers for my AC system in the bus, and I have little watt meters built into the breaker panel so I can actually monitor how much load is on the system at a given time. So, and then that runs through there all the way up to a socket here where I have a little carbon monoxide heat detector for since I'm running a kerosene heater in here, and it goes out to my air conditioning system, which I haven't finished putting in all the 110 outlets yet, but that's basically how it works. This inverter charger is capable. I can change the DC amps or AC amps coming in so that it's compatible with just a regular plug-in and extension cord, and it also will tell me kind of what the DC amps that it's pulling out if it's actually inverting. So right now that's not illuminated, indicating there's no inversion power being generated or made. And then these are the status of the batteries, and if they're full, I can go through here and make some other options. So there's my actual inverter right here. I have everything hooked in here. That's the remote cable that goes to my breaker box and my 300 amp fuse. And pretty much I have these two are 6-volt golf cart batteries that I have wired in to make 12 volts in series, so they're acting as a single battery. And then I have cables going through this bulkhead, which I'll show you in a second, that hook into the regular 12-volt system of the bus. So I have these coming from this battery, and then I have a negative and a positive going through that bulkhead into the engine compartment in the back. All right, and then here's the engine compartment area. I made the scoop. I moved it from up there to down here. I've been testing it. It ventilates. It gets as much air, at least as much as the stock system. So here's everything that's coming through the bulkhead right here. This is just a small ground for this relay. This relay protects the start batteries from being used as a power source for the inverter. So the way that this is wired in, since the alternator is already part of the 12-volt system, I have the cables just going straight to these leads that were already on the alternator. So when the bus is running, the alternator can pull DC in directly from the alternator, which is like a generator in and of itself. I mean, it is a generator. And it can also pull through the alternator into the start batteries, running or not running, and then it can pull off of the other batteries. And depending on, it would probably only do that in a really high load situation, or like say for like it surged when it just turned on the air conditioner or something like that. So that allows it to pull that DC power from all those different places for a short time. I wouldn't want to run it completely just off of the alternator for the simple fact that it might probably wear it out. So that's what the setup is in here. It turned out pretty good. And then here's my little shore power plug that I have that's hooked up to a regular outlet in my garage. All right, quick general update on the bus. Got the electrical system, at least the bones of it, put in for the 12 volt and for the 110 AC. You can kind of notice that I got the paint pretty much done on the inside. So it's kind of a two-tone white and gray paint, and I'm about ready to start doing the flooring. I've had a continuous problem with leaky windows. They was actually leaking underneath the window seal, the part where the seal actually mates up with the glass, not the frame, because I had already sealed up the frames, I think, pretty good. So hopefully the next storm that we have come through, I'll get a nice, or next heavy rain, I'll be able to do a really thorough check and make sure that the windows are actually sealed up. Next up, flooring. So flooring and maybe again the wheel wells, going through and trying to build some insulation around the wheel wells. So stay tuned. If you like the bus project, subscribe to our Instagram and our YouTube channel. We have the websites actually up now, and I'm going to have some written articles, especially with the components and everything, like what exactly specifically is in the electrical system, for instance. That's going to be a really good one, and just kind of a detailed materials list to document pretty thoroughly everything that we're doing on the bus. So go to rogueonebus.com and check it out.